For the last couple of days, as we've been solving systems of equations by elimination, we've been fortunate enough that either through straight addition or subtraction, one of our two variables has always been able to cancel each other out. Today we're going to start taking a look at a scenario where that is not going to happen necessarily. So if you take a look at example 1a in your notes, you're going to notice that if we were to take our two equations and add those two together, our negative 2x plus 10x is going to end up giving us 8x, and so those aren't going to cancel each other out. And if we were to take negative 5y and add 3y, that's going to give us negative 2y, which also will not cancel each other out. So then maybe you think, well, let's try subtraction. But if we take negative 2x and we subtract 10x, that's going to give us negative 12x. And if we take negative 5y and we subtract 3y, that's going to give us negative 8y. So this is a scenario that we haven't seen before, where we cannot just add or subtract our two equations, and one of those two will eliminate one another. So what this means is we're going to have to adjust one of our two equations. And when I say adjust, I don't mean like solve for a different form. We like our x's to be in the columns they are, we like the y's to be in the columns that they are, and we like the constants to be in this particular column. What I mean by adjust is we actually have to change one of the equations a little bit. So if you recall back to the movie theater problem that we did the other day, one of the problems that I asked you to do was you could actually answer by taking one of the scenarios that they gave and simply doubling it. And so I believe the question was, if there was 2 adults and 3 children, how much was it now going to cost for 4 adults and 6 children? And so what we discovered was that if you just doubled that amount, you could actually double the entire equation and not change the values of the variables. And so really that's what we need to do in a problem like this. We're going to have to identify a variable that we would like to get to be the same and change the entire equation in a way that it doesn't change the values of x and y. So as you look at example 1a, what you'll notice is that 2 is a factor of 10. Simply meaning that if I multiply 2 by something, I could change that 2 into a 10. But I can't just change my negative 2x into a 10 without changing the rest of the equation, because otherwise I'm changing my values of x and y. So whatever I multiply or divide, because sometimes I might choose to do division, whatever I multiply or divide this x by is the same thing that I must multiply my 5y by, and it's the same thing that I need to multiply the 22 that's on the right-hand side by as well. So if we, without a whole lot of thought, hopefully we realize that if I were to multiply negative 2 by 5, that's going to give me the same coefficient as my x in my second equation. And again, remember we talked about this the other day. We don't care if they're positive and negative, or if they're two positive numbers. We're looking for the coefficient on that variable to be the same. That's ultimately what we want to have happen. So let's go ahead and manipulate our first equation so that we can make it look somewhat like our second equation. So what we're going to do is we're going to multiply this entire first equation by a factor of 5. And again, we need to make sure that you multiply every piece of this by 5. So your negative 2x is going to get multiplied by 5. Your 5y is going to get multiplied by 5. And most importantly, because a lot of times students will forget to do this, the 22 is also going to get multiplied by 5. So if we multiply the entire equation by 5, the resulting equation is now going to be negative 10x minus 25y, and this is now going to equal 110. So all we've done is we've taken our first equation, multiplied every value in this by 5, and came up with a new equation. That's allowed as long as we change the same, or the entire equation, by that same factor. In this case, we multiplied everything by 5. Now, the second equation, we actually don't need to change at all. Right? We already have a 10x, which is what we want in front of there. So below this, we're going to just rewrite our second equation, which is 10x plus 3y is equal to 22. And now, what we've done is we've made this problem look like one that we've done the last couple of days, where the numbers that are in front of the x's are the same, except one's positive and one's negative. And the numbers in front of the y's, whether they're the same or different, don't matter to us. So now what we've got to do is we've got to determine what operation we're going to do between these two equations to eliminate them. And as we've talked about the last couple of days, if we have opposite signs, which is exactly what we have here, opposite signs tell us that we need to add those two together. So we're going to add each column straight down and hope to eliminate our x's. So if we take negative 10x and we add 10x, that's going to give us 0 x's. So that's eliminated. That's what we're looking for here. If we take a negative 25y and we add 3y, that's now going to give us a negative 22y. And on the other side, remember that this had to change to 110. It didn't stay as a 22. We're going to take 110 and we're going to add 22 to that, which as a result gives us 132. So if I were to divide each side in this equation by negative 22, that's going to give us the value of y, and it turns out that y is equal to a negative 6. Okay, and again, that's only 1/2 of the answer, so the next thing that we have to do is figure out what our x is. Okay, but here's what I'd like to point out. We talked a little bit about this yesterday. You have the original first two equations that you were given in the problem. Your negative 2x minus 5y equals 22. You were also given 10x plus 3y is equal to a positive 22. But now you've also come up with a third equation as well. So you can also plug it into your negative 10x minus 25 equals 110. And since the first and the third equation are really the equivalent equations, it doesn't matter which one of those two that you plug it into. So you plug it into the first, the second, or the third. That doesn't matter to me, whatever you're the most comfortable with. But you're going to take the value of y, plug that in, and then solve for x. So let's go ahead. I'm going to actually plug it into the second equation here. And we're going to have 10 times x plus 3 times negative 6 is equal to 22. And then we go ahead and we proceed to solve that equation for x. So 10x minus 18 equals 22. If we added 18 to both sides, that means that we're going to get that 10x is now equal to 40. And finally, when I divide each side by 10, the resulting part is that x needs to be equal to 4. And since I used the second equation to find the value of x, I've always been talking about making sure you check your answers. Use your first equation to check it. So negative 2 times 4 is going to be negative 8, minus 5 times 6, negative 6, which is negative 30. And so if we take negative 8 and we subtract a negative 30, that's actually going to give you your positive 22. So that's the answer to that first system of equations. X is 4 and y is negative 6. Now, if we take a look at example 1b, very similar idea here. If we try to identify if this is an addition or subtraction problem, we're going to note that right away, if we add these together, we are not going to eliminate our x's or our y's. If we subtracted these, again, we're not going to be able to eliminate our x's or our y's. So in order to actually make this a true elimination problem, we're going to have to adjust one of the equations. And the one that jumps out at me is, again, the very first one in this particular problem, because 2 is a factor of 4. And so what I'm going to do is I'm going to multiply this first equation by 2, so that way my y's turn out to be the same values here. Again, the important thing to remember is that every piece of that equation must be multiplied by 2 in order for you to not be changing the values of x and y. So if that's the case, we're now going to have 6x minus 4y is equal to a negative 8. And for my second equation, it's going to stay the same as 7x minus 4y is equal to a negative 6. Now, we got the same value that's in front of the y's. What we need to determine is, are we adding or subtracting those? And since they are the same signs, they are both a negative 4y, that's going to tell us that we're going to need to do a subtraction problem. So if I subtract our columns here, we'd have 6x minus 7x, which is a negative 1x. My negative 4y minus a negative 4, minus a negative means I'm adding. That's going to give me 0y. And then if we take negative 8 and we subtract a negative 6, that means you're actually adding 6. it's going to end up giving you x is equal to a negative 2. So solving that equation, divide each side, of course, by negative 1, and x is now going to be equal to a positive 2. And once I know what x is, again, I can go to my first, my second, or my third equation, plug that back in and solve for y. Okay, I'm going to go back up to my first one. We're going to take 3 times 2 minus 2y equals negative 4, and then solve that for y. So 6 minus 2y equals negative 4. If I subtract 6 from each side, then negative 2y equals negative 10, and divide each side by negative 2, and y turns out to be equal to 5. I plug that back into this second equation here. 7 times 2 is going to be 14, minus 4 times 5, which is 20, and 14 minus 20 is in fact negative 6. So go ahead and pause the video for a moment, and you work through example C, and once you've worked through the entire thing, then unpause it, you'll see my work, and check your answer to see if that's the same thing that I received. For this third example here, what we're going to have to do is we're going to have to multiply the second equation by a factor of 3. And that's going to make my 2y into a 6y that matches that first equation. So the first equation is going to stay as 3x plus 6y equals negative 6. And my second equation is now going to become negative 15x minus 6y, and that's equal to a negative 42. So that's the system that we're trying to solve here. We'll notice that our y's are opposites of one another. One's positive 6 and one's negative 6. So opposites tell us that we always like to add. If we take negative 3 and take a positive 3 and add negative 15, that's going to be a negative 12x. My 6y plus negative 6y gives me 0. And negative 6 plus negative 42 is a negative 48. If we divide each side by negative 12 to solve for x, turns out that x is equal to a positive 4. And I'm going to take that and plug it back into my top equation and solve for y. So 3 times 4 plus 6y equals negative 6. That means that I've got 12 plus 6y equals negative 6. We subtract 12 from each side. 6y now becomes a negative 18. And then divide each side by 6, and y should turn out to be equal to a negative 3. If I take that and plug it into the second equation for this, negative 5 times 4 is going to be negative 20. 2 times negative 3 is going to be negative 6. If I take negative 20 and subtract a negative 6, that's what's going to give me a negative 14. Alright, let's go ahead and take a look at the back page of this stuff. So if we flip it over and take a look at example 2a, again, what we're going to notice is you cannot just add or subtract, as we've talked about before. You're not going to eliminate your x's or your y's in either one of those problems. Okay? But here's the other thing you're going to notice. If I multiply 4 by something to get 7, that something is not going to be a whole number. It's going to have to be a decimal. And I really do not want to have to do that. And the same thing if I multiply my 2 to make it into a 3, I'm going to have to multiply that by a decimal, and that's also something that I really don't want to have to do. So, what I would do in a problem like this, where I cannot manipulate just one of my equations to get them to be the same, we're going to change both of them. Okay? Now, in order to change both of them, we're going to go back to last year a little bit, and we're going to give a quick definition. So if you flip it back over to the front page of your notes, we're going to talk about what a least common multiple is. So we called that last year the LCM, and we talked about least common multiples when it came to adding and subtracting fractions, where you had to have a common denominator. So, our definition of a least common multiple says it's the smallest number that is a common multiple of 2 or more numbers. The smallest number that is a common multiple of 2 or more numbers. So below this, I've got a couple of different examples. So first of all, if I were to have 6 and 8, now 6 times 8 is 48, but 48 is not the smallest number that both 6 and 8 have in common. The least common multiple of 6 and 8 actually happens to be 24. Whereas if I have 3 and 5, the least common multiple of 3 and 5 is 15, which happens, of course, to be 3 times 5. So sometimes multiplying those two numbers will be multiple, and other times they will not. All right, so now that we've got that definition, let's flip it over to the back page. Okay? Now here's the thing. If you are going to be changing both equations, on the first 3 examples, we pretty much always chose the same equation to change, or chose the same equation to change. But if you're going to be changing both equations, ultimately it doesn't matter what you choose to multiply by. So if I know that I'm going to have to multiply the first and the second one, I could multiply those together to get the x's to be the same, or I could choose to multiply those together to get the y's to be the same. And so this is where one person might do it one way, one person might do it another. It is completely up to you. As long as you've got all the work that shows with it, I'm completely fine with that. So let's take a look at example 2a. So what I'm going to do is I'm going to multiply my first equation by 3, and I'm going to multiply my second equation by 2. And by doing that, we're going to get the same number of y's in each of these equations. So the first equation is now going to become 12x plus 6y equals 42. And our second equation is now going to become 14x minus 6y equals a negative 16. Now, here's what I'm going to point out, so that way when it comes back to plugging these back in, you now have your first and second equations that were given, but now you've got a third and a fourth that you come up with. So when you go to solve for your variable, whichever one you didn't solve for first, you can plug it now back into any one of those 4 equations to find the other variable. All right. So when I look at this particular problem, we're going to notice that the values in front of our y's are the same, except one is a positive 6 and one is a negative 6. So a reminder that if we have opposites, that we are always going to choose to add these two together. So as I add my columns down here, 12x plus 14x gives me 26x. We take our 6y and add negative 6y to get 0. And if we take 42 and add negative 16, that's also going to give us a 26. So solving this for x, we divide each side by 26, and x now becomes 1. Again, I've got a choice to go to my first, my second, my third, or my fourth equation, any one of those, and plug it back in to solve for y. Okay, I'm going to go back up here to my first one. I'd have 4 times 1 plus 2y is equal to 14. So 4 plus 2y is equal to 14. Subtracting 4 from each side means that 2y is now equal to 10. And if I divided each side by 2, y is going to turn out to be 5. If I plug that back in here, 7 times 1 is 7, minus 3 times 5, which is 15, and 7 minus 15 is going to give you negative 8. All right, so now let's take a look at example B. Again, we'll notice that our x's and y's are not the same, and I'm not going to be able to just change one of my equations. I'm going to need to be able to change them both. So, you pick a variable that you want to be the same, and get them to be the same through multiplication, and then solve from there. All right, I'm going to go ahead and choose to get my x's to be the same. So I'm going to multiply the first one by 5 and the second one by 3. And when I do that, I'm now going to have 15x plus 25y is equal to 50. And for my second equation, we're going to have 15x plus 21y is equal to 30. The value in front of the x's are the same. They're both positive 15. So if I have the same number with both of them, that tells me that I'm going to do a subtraction problem. So if I'm going to go ahead and subtract these two, 15 minus 15 gives me 0. 25 minus 21 gives me 4, so this becomes 4y. And 50 minus 30 now becomes 20. Divide each side by 4. And when we do that, y turns out to be 5. And once I've got y to be 5, take that and plug it back into one of your two equations and solve for x. I'm going to plug it back into my very first one here. So 3x plus 5 times 5 is equal to 10. So 3x plus 25 is equal to 10. Subtract 25 from each side. So that 3x is now equal to a negative 15. And if I divided each side by 3, then x is now a negative 5. 5 times negative 5 is negative 25. 7 times 5 is 35. And negative 25 plus 35 gives me 10, which is what I needed for my second equation. So again, at this point in time, go ahead and pause the video and work through example 2b. And then once you think that you've got that done, you can go ahead and unpause it. And I will have this example worked out for you. In this particular problem, I chose to get my y's to be the same, but I'm not just going to multiply the top by 10 and the bottom by 8. I'm going to find the least common multiple of those two, which is 40. So I'm actually going to multiply the first equation by 5 and the second one by 4. That's now going to give me 35x plus 40y, and that's equal to 125. And my second equation is going to become 36x plus 40y is now equal to 140. I've got a positive 40 and a positive 40, so in order to eliminate those, it tells me I'm going to need to do a subtraction problem. So 35 minus 36 is going to be negative 1x. 40y minus 40y is now going to give me 0. And 125 minus 140 is now going to be a negative 15. If I divide each side by negative 1, that means that x is actually a positive 15. Okay, now I usually like to go back to my first two equations, one of those two simply because the numbers are smaller. It's going to make it a little bit easier computational work. Let's go back into the very first equation here. So I'd have 7 times 15 plus 8y is equal to 25. If I multiply 7 by 15, that's going to give me 105 plus 8y is equal to 25. So if I subtract 105 from both sides, that means that 8y now becomes a negative 80. And if I were to divide each side by 8, y is now equal to a negative 10. If I plug that back in here, I'd take 9 times 15, which should give me 135. 10 times 10 times negative 10, which is going to be a negative 100. And 135 plus negative 100 is now going to give you a positive 35 like we needed. All right, the rest of the class period you will have to be able to work on your homework assignment. Let's make sure that this is done and ready to go for tomorrow. It is going to be page 396, and I'd like you to do numbers 2 through 20 evens.